Welcome to Elegant, where all the unknown facts of the universe are explained in more details to help you understand the cosmic universe and its anomalies that make up the surrounding bodies that drive our interest to explore more. Let's dive into today's topic, black holes. Space is vast in size and full of strange objects. Astronomers and scientists have gazed at the stars for years trying to determine what is in the center of our cosmic monsters, the black holes. Most astronomers and scientists have come to the conclusion that the center of a black hole is a fine point of infinite matter that once anything including light that travels beyond the event horizon is doomed to the infinite gravity and cannot escape. With new findings that occurred within our own galaxy, astronomers have discovered two red giants that have gone supernova that orbited each other. With showing no visible matter around the two stars and both stars are around the same size, the first red giant that went supernova turned into a black hole, and the second red giant that went supernova turned into a neutron star. Now, using models and physics of the events, the collapse of the stars should have been the opposite of each other. The first red giant that went supernova could have turned into a black hole or a neutron star. However, the second red giant with the equivalent mass as the first red giant should have turned into a black hole, as it would have received the blast residue of the first red giant, giving it more matter to ingest. The event has opened up new gateway ideas for how the universe works. Black holes are formed when a star, gas cluster, or object in space with large amounts of matter collapse on itself, forcing the gravity of the outer layers to compress against the core and compress it to an infinite point. Black holes are strange in nature and cause a gravitational lens effect, bending light as the monsters cross paths in front of nearby objects that are emitting light. However, black holes do not emit light in the black area known as the area past the event horizon. All astronomers and scientists have discovered that due to the immense gravity, black holes do not reflect light as the gravity is too strong to allow the light to shine through the event horizon. Physics shows that light that moves from one location to another and is bent by an obstruction, the light as it bends moved into an emptiness, shows the light wavelengths shrinking, indicating that the light beams are fading. With that said, all black holes should show some form of light bending or fading from the event horizon to the center, but that is not the case. For a black hole to stop the light from moving from the event horizon to the center, there must be an obstacle obstructing the path. In fact, the center of black holes may even be something else other than the center, which would explain the strange light disappearance after the event horizon. The center of black holes could be a shell of dark matter shrouding the core of the original star, gas cluster, or object, similar to a Dyson sphere. A Dyson sphere is a hypothetical megastructure that encompasses small captured stars to harvest the power from the star's energy. The housing around the core could be a material that does not transmit light and does not reflect light either. Dark matter is a unique substance that astronomers and scientists are still trying to figure out its mass structure by only relying on the existence of the gravitational effects that dark matter has on visible matter. The only interesting fact about the center of black holes being shielded by dark matter is that dark matter does not absorb, reflect, or emit light. However, if dark matter was in front of an object with visible matter that emits light, the lens of a telescope will still show the visible matter that is behind the dark matter. On the other hand, dark energy is more powerful than dark matter, filling in the gaps around dark matter and visible matter with some sort of energy fluid or field. The core of black holes could be surrounded by dark energy, giving the illusion that the center of a black hole is black in nature and does not reflect any visible matter light. This would explain the reasoning behind the mystery of the light disappearance between the event horizon and the center of black holes. Dark energy is strong by force, which using supercomputers and gravitational programs can provide astronomers and scientists with a leveraged means of data of how dark energy keeps galaxies together and prevents them from falling into the abyss of voids and other unknown areas of the universe. As black holes grow in size, the gravitational force becomes stronger but less attractive to objects falling past the event horizon. If black holes have dark energy shielding the core, the gravitational force would become stronger as the mass of dark energy becomes larger in size. This would explain the phenomenon behavior of objects falling into black holes viewed from outside the black hole accretion disk. The object would still be falling into the black hole going through the dark energy, making the illusion that the object has stopped moving in its tracks due to the large gravitational force. The illusion would be caused by gravity stopping time to both viewers, the object falling into the black hole viewing an individual or camera watching them, and the individual or camera viewing the object falling into the black hole. If a person or camera were to fall into a black hole, two things would occur as they continue to travel towards the core of the black hole. The first sight would be watching all of the known visible objects in space spin up dramatically fast, indicating that time is moving faster outside the black hole than inside. The second sight would be watching the light from outside the black hole shrink to a complete darkness as gravity begins to stop photon beams from moving due to the gravity growing stronger as the individual or camera gets closer to the core, with black holes having a Dyson sphere effect as if they were housed like a megastructure with dark energy. The dark energy would apply opposing forces towards the core, balancing out the gravitational tug and cause them to grow with each other as black holes feed on nearby objects. The core of a black hole, or known today as the singularity, would grow in size along with the outer shell of dark matter or dark energy as objects in space get too close to the gravitational pull. As two black holes dance around each other and then merge into one supermassive black hole, a ripple effect is stretched across the universe as the gravity becomes doubled in strength. Plasma jets and materials shed away from the merger and cause new stars and galaxies to be born. The question of the ages has always been, how can a black hole become so massive right after the Big Bang as there was not enough visible matter, like what is shown on most modern telescopes developed today? Dark matter or dark energy surrounds the cosmic universe and could be the answer to the question. Since visible matter may not have been everywhere from the birth of the Big Bang, as scientists and astronomers see it today, black holes may have formed from dust clouds and shield themselves with dark matter or dark energy. Each black hole that is referred to as a supermassive black hole that is billions times the size of our Sun were packed with dense materials that may not have been available to the visible matter right after the Big Bang. Therefore, the supermassive black holes may have formed pulling in more dark matter and shielded themselves with dark matter or dark energy, creating an enormous dark center as large or larger than our solar system. Holes, our cosmic monsters, have become the building blocks of the universe that we see it today through our telescopes. Check out our video on time travel and the reality of how black holes affect time. Thanks for watching, and don't forget to subscribe to our channel, along with sharing and liking this video.